just do a quick update on the display. You see I've just been mucking around with it, drawing a schematic. I have a picture of the display here um, that I took a little while ago. Someone asked me if I could go over the various things that are happening on this display. Sure, I could do that. Um, well, we've got 3 ICs on here. Well, 4. Technically, we have 4 ICs. Okay, so we have 4 ICs on this display. We have the microcontroller. We have a supervisor IC, which is that little guy right there. We have an EEPROM, and we have a DAC. Okay. Um, the DAC is being used for the contrast. The EEPROM is being used to store user settings, where it was, last channel, so on and so forth. There's not a whole lot to be gleaned in that EEPROM. It's not very big and it doesn't store very much. What I can tell you, however, is that this thing has a sort of freak out mode, um, which is more like a uh, preventive, basically to prevent you from screwing around with it very much, where it'll overwrite all the data in the EEPROM and then it won't boot. Um, so yeah, it works fine with a blank EEPROM, which is interesting. But if it when it goes crazy, it writes all just gibberish into it. I'm not sure if that's a software bug or a countermeasure of some kind, but if you blank it, it's fine. It's bizarre. I believe it's probably more like a software bug, and that's why I was screwing around on the data bus. And just this is using a 2-wire, and the DAC is using a serial, like SPI. And these share 2 different buses. So it's not like I garbled the EEPROM because they share the bus. They don't actually share the bus. This is on its own bus. So the DAC and the PLLs, the 2 PLLs in this radio, and the IO expander are all on the SPI bus. And they of course have their own dedicated chip enable lines and so on and so forth. It's SPI. So then we have the microcontroller, which is very interesting. It's just an old obsolete Renesas, or formerly NEC microcontroller, that's quite old. By today's standards, it is. It's pretty much just an obsolete component. I'm not sure why. Well, I know why Uniden continues to use them. It's probably because, number one, they have a whole boatload of them, and number two, they've standardized on using these CPUs, so that's what they're doing. As you can see, we've got just tons of jumper links all around here, and I believe this is to facilitate routing more than anything. They're kind of a handy debug tool because I got a pair of tweezers. I can just get in there and grab a hold of it, pull it off. Hot tweezers, for soldering. You just grab the component, pull it off, and then you can measure voltages and just see what happens with things. So I've only pulled a few of them off and stuck them back down. It's no big deal. They don't really do anything. It's just mapping out the pins. Now the LCD in here is a passive display. So if you don't know anything much about passive displays, I'll basically things like calculators and things like that use passive displays. They're not active displays. They don't have transistors in them. It's pretty much you have to use a square wave or the like to drive the segments. And basically, if you encounter one of these displays, and you pretty much know right off the bat that whether it's passive or active, because a passive display is going to have obviously a lot of connections. This is more connections than 36 connections is not reasonable for an active display, because it's going to be a data bus. It's usually a parallel or serial bus that's going to go into it. Maybe you'll have some other things, but you certainly wouldn't have this many connections. Another thing of note is that the display pattern is fixed, so that also generally indicates it's passive display. And the way you can really test whether or not, or to find the segments, is you have to find commons and of course the segments. Like all the segments are tied to buses internally for common segments, and so this one has 4. So you'd have, like, say, this pin and this pin will do a segment, and this pin will do a segment somewhere on the display. So this one has 4, and these pins over here. which correspond to segment 0 through 3, or just common 0 through 3 in this microcontroller. Um, it's just fantastic that it turned out that way, because it makes things simple. Uh, but if you wanted to find out what they do, you just get a signal generator, 100 hertz, 100 hertz square wave, like 1 to 2 volts, anywhere from 1 to 3 volts peak to peak, typically around 2 volts peak to peak, and then just um, touch your leads to the various pins until you find one that lights things up, and then remember what pins those were, and then try other pins, moving them around, and then eventually will find the commons. They're typically going to be on one side or the other. Very rarely will they be mixed into pins. They're generally going to be on one edge or the other. Um, so, in this case, it's the 4 commons is 0, 1, 2, and 3 there. Um, so it's pretty much you touch a lead here, and you touch a lead here, and then you're going to illuminate whatever segment is attached to that. Um, so other than that, there's not really a whole lot else going on here. We got like I said here, we got our DAC. Um, this is being used for contrast. EEPROM being used for user data. Um, we've got a bunch of uh, a lot of passives and things like that. We got some debounce here for the encoder, some hardware debounce, um, which is interesting, because this only has one debouncing for one pin here, and I believe that there's 2 on here, the up and down, and we only have one debounce, so that's kind of it's kind of strange. But and then the supervisor IC, also called, a lot of times called a reset IC. It's looking for the power conditions to be good, and then it issues a reset to the microcontroller. Basically, just drag the reset pin low, and it's just pretty much all it does. These are actually a common failure point in some electronics. They will short themselves to ground, and then you'll have something that appears dead, when in fact it's just because the reset line is just being dragged down, it's being held and reset. So it doesn't do anything. Of course, once you remove it, you'll find out that it tends to work just fine once you manually pull the reset pin low, just by touching it to ground real briefly, just to give it a reset. And then of course when you turn it off and on, you're not guaranteed to get a reset, so of course it won't work. It's just a little. Most of them are 3-pin. They use 3 connections. This one has 4. One connection is not used. This is a reset right here. You can see it goes through 0 ohm resistor and up to the reset pin. This is obviously ground, and this is where it's supervising the power. We've got these caps here, uh, to smooth things out for it. Um, so it's pretty much just looking for the voltage to cross a certain threshold, and then it issues a reset. That's pretty much its goal in life. So once the voltage goes below a certain threshold, it'll drag that pin back down again, so it causes micro to reset. Um, they're kind of handy, but it's probably because this doesn't have a built-in brownout detection like an Atmel does. So they have to have an external supervisor. Um, so if you ever have one of these radios and it just sort of seems dead for whatever reason, this one of the first things you're going to check, other than voltage, is do I have 5 volts? Do I have 8 volts as pads for that? Do I have these voltages? If I have these voltages, and the third thing, believe it or not, I'm going to check is this: is my reset high or low? If it's low, then I'm being held in reset. So why am I being held in reset? Is it because my supervisor IC has failed, or is it because my microcontroller has failed? And that's exactly what the purpose of these these jumper links are that they've put in here. You can just grab this with a tweezer, pull it off, and if your radio starts to work again, well, then you know you got a bad supervisor IC. Be surprised how many receivers I had seen when I worked consumer electronics that actually had bad supervisor ICs. Some Onkyo receivers were quite notorious for having some of the supervisor ICs fail in them, and then of course it just wouldn't, it would be, the customer complaint would be dead, and it would just be a supervisor IC. So anyways, if that's typically okay, the next thing you're going to do you have clock? And if you have clock, the third thing you typically would check is, are any of the buses dragged down? Like these 2 pins and this guy right here in the EEPROM are going to be clock and data. Um, and these are pulled high typically. So these are going to be fairly close to your 5-volt rail. If these are dragged low, you're going to have boot problems, particularly when it's trying to read a EEPROM and it can't. So, and that's for a lot of things, not just this radio, but even like aforementioned receivers. Um, uh, if your if your data bus is being dragged, it's not going to, it can't communicate with anything on the bus. It just will sit there in a freaked out state. And this is actually true of this radio. If I attach things to the SPI bus, um, it will actually freak out. There is a countermeasure in this. Okay, so I want to be clear about that. There are countermeasures in this. If you attach, like when I attach my Saley Logic to the bus, it won't boot. In fact, if you try to put the resistors between like my Saley Logic and this bus, it still goes weird. That's when I get the EEPROM corruption. So I think there's some countermeasures in here to try to prevent you from sniffing the bus, but I've been successful at doing it because those sorts of countermeasures are just, you can get around them. They're just, as a famous YouTuber says, trap for young players. So yeah, if you're gonna probe around on this, you got to be careful that you don't trip some apparent countermeasures that they have in here. Contrary to what you might see here, TXD and RXD, that is not serial data. That is programming, and actually also display. I don't recall what the programming sequence is, but you probably have to hold a reset, and then use it for programming, or pulse something to, I don't know what FLM. I haven't really figured out what these things are. It might be that you have to pulse something or hold something on here, high or low for the UART to be enabled, because that's what that is for. It's for a UART. So uh, you're not really gonna get a whole lot of this. This is locked. There is no reading this microcontroller. I think you can blank them, but that kind of defeats the purpose of, if you blank it, then what's the point? You lose the program, and the program is what you're after. So there's no point in it. So anyways, the board. This is what I've got so far. You can see I've tied all of my pins. I've got my commons, and I've got my 34 segments. Uh, so I just have to start laying tracks down. The biggest problem I have with this is to get these dimensions right, to get this position in the right place, and get these positioned in the right place. Um, these mounting points are the top edge of the board. That's as far as I've gotten. To get this in the right place and get these in the right place. There's a cutout that is approximately right here for those metal tabs that are on there. And see these metal tabs? There's some cutouts. So I'm going to have to, get these cutouts, and of course get this cutout put in precise locations. There's one here, and this one's on the edge over there, so it's just notch that out. That's no big deal. Um, and these are not soldered, which is also very interesting, because typically they'll solder these, and they have provisions to solder them, but on mine they're not soldered. Which is, again, like I said, so sort of interesting. I guess they felt they didn't need to solder the metal cage. That's the metal cage that's over the LCD. You just loosen those up, and I mean, it's not like the only thing that'll come off is a metal cage. Nothing else will come out. So they probably just deemed it unnecessary to solder it. Um, of course, we got footprints down there. I've got to add the rest of the footprints, but I needed to get the orientation of this correct, and try to get this top edge of the board correct. Now this is squared off because, well, the original one is not. It's rounded a little bit, but where it fits in the radio, it's not necessarily. It's not necessary for it to be rounded, and try to figure out and get that going. But this is necessary that this be this shape. Um, because of where it's going on the faceplate. It has to be rounded like that, and as a result, of course, you can see where I've rounded that. Um, so that's pretty much it. A lot of component placement needs to be done. I need to reverse engineer the illumination, the diode positions for the LEDs. Those all have to be done. Basically, this is the hardest part. I have to sit here with a board, okay, and I have to mark out and measure precise locations to the centers of like these mounting holes. With some calipers, I have to measure everything out, everything. Where these rectangular slits need to be cut. Um, all these holes. You see, we got a pin alignment hole there. And I believe it's no, there's another one there. These alignment holes for the display. They have to be, done somewhat precisely. Um, so it's a very interesting process. This is also an alignment hole for the front panel. So all the alignment holes, all these things, these all have to be done and cut out. And yeah, it's going to be very interesting, for sure. So, anyways, that's pretty much it for the display. I hope you guys found all of this interesting, informative, and all that wonderful stuff. And for the Americans, Happy Americans Birthday or America's Birthday or whatever, but they call it Independence Day. Happy Independence Day to you. It is the uh, 4th of July. And this is the day where all of my neighbors, they make tons and tons of noise, and I don't like it. It's just I'm not really too big into to big bangs and things. It's just I prefer the quiet, but fireworks are legal in the states where I am right now, so they tend to get some big bangs going. I'm trying to remember while I'm thinking about this and just sort of rambling on here. There's some guys that every year they're like in Finland or Sweden or something, maybe Norway, and they get a wash machine, uh, and they and they throw one of these absolutely humongous um, fireworks into the thing, and it blows the thing completely to bits. They do it in like a cornfield or something, where there's sufficient area to run away and hide, and it blasts the thing into just fragments all over the place. It's quite fun to watch. But anyway, it's all over in about 2 seconds flat when it explodes, but it's still humorous. But anyway, guys, take care of yourselves, and for the Americans, be safe. Do not injure yourselves, and till next time.